Good morning. I'm sorry, but I do speak Czech, but only on Tuesdays. So you're out of luck. So it says up there, VP and CTO EMEA. You heard my boss, Pat Gelsinger, talk about innovation. At VMware, innovation is my job. I'm part of the Office of the CTO, and the team that works with me works on building the next generation of technology for you and making sure that it works and is incredibly good at an operational level. So what I want to do for you today is explain a little bit of history about where VMware has come from and some of the innovation that we've done. But then I'm going to talk to you about how I see, me personally, the market going forward, what I see happening with applications, what I see happening with infrastructure, and what the future will hold for you in the next 5, maybe 10 years as you go through the next phase in our industry's history. Now, some of you may be wondering, what is this chromatography? You'll find out. It's okay. The chromatography actually is the same word in many, many languages, so I think we're probably okay. So VMware, we don't build a stack. Okay, that's important to understand. Many other companies will try and sell you their whole stack, end-to-end stack. We don't build a whole end-to-end stack for you. What we do is we bridge across silos of innovation and bring you platforms. What we do is we give you choice, and we enter you into a world that is more open than you were in before. And we have done this for 20+ years. First of all, we helped modernizing data centers. And in modernizing data centers, what we did was we allowed you choice of what hardware you ran your applications on. Through virtualization with ESX, you no longer had to be stuck with one particular type of hardware or one particular server. We now gave you the choice to swap that out underneath. Likewise, at the other end of IT, we've empowered the digital workspace with Workspace ONE, meaning that we can enable you to deliver applications and data securely to any type of device, including Chromebooks. We're the only people that do Chromebooks for you. So again, bridging across silos and giving you the ability to deliver your applications and data to any device that your end users choose. And up here, you'll see we list major things like Android and iOS, but it also includes Coke machines and wind turbines and cars and ambulances. We've transformed networks. Through virtualized networking with VMware NSX, we now mean that you no longer need to tie yourself into one particular physical network provider for on-premises networking and for cloud networking. Through one virtualized layer, again, you have choice. You can choose between multiple vendors or any firewall or load balancers, and in fact take a lot of that functionality and now do it in software. And now, as people enter into the multi-cloud era, VMware is there for you, enabling you to deliver applications and data securely from any cloud. Be that your own private cloud, be that the public cloud, or be that your deployment of the hybrid cloud in between that, or all three. We enable you to have that choice. You can run VMware technologies on pretty much every cloud available today. And at the same time, you can run pretty much any application. And I'll talk more detail about what you can do and what we're doing next a bit later on. We've built a solid, and frankly, I'm very proud of, our reputation. This is the results of a survey of 800 IT decision makers of companies of more than $250 million worth of revenue, asking them which is the technology company, and that's all technology companies, every tech name you can imagine, would they recommend the most to their peers. And I'm proud of the fact we've always been in the top 5. And back again, the last few years, we're back up in number 2, number 1. Now, you could probably look at that and think, well, what happened? Well, back in 2013, we were leading the world in the software-defined data center. We defined and invented the software-defined data center. I'll talk to you about that in a minute. And then people have been playing about, maybe trying different clouds, are now realizing that the future is a multi-cloud world. And the one organization, the one family of companies that can give you answers to all of the multi-cloud questions is the Dell Technologies family, and specifically VMware. So let me tell you how we got to be number one and how we're going to stay at number one. And more importantly, what we see in the market. So we're facing down a lot of change right now. Many people will tell you, this is the fastest rate of change you've ever experienced in your life. There's so much happening, it's all happening so fast, so many things are changing, it feels overwhelming. I wouldn't say it's necessarily faster than before, it's just many more things than before. If you look at each of these technologies, none of them has just appeared. Cloud has been around for more than 10 years. Mobile has been around for a lot longer than 10 years, and effectively from the iPhone, just more than 10 years. AI and ML is a 50-year overnight success that has been going on for a very long time. And Edge and IoT, yeah, maybe the last 4 or 5 years. Nothing's happened just in the last couple of years. But what's the difference? They're all happening together. That is what's overwhelming, and we've not had that before in our industry. And what's great is that each of these is incredibly powerful. If we look at cloud, people now have access to unimaginable scale. Now, from your phone, from your pocket with a credit card, preferably a really good credit card, you could access literally the equivalent of supercomputers, as much power as you desire, and as much scale as you want. You want to spin up a global company and have a digital presence in every single continent in the world, you can do that from your hotel room in a matter of minutes using cloud. Mobile has put technology into people's hands that they never expected before and given you unprecedented reach. I always laugh because when I was at school, we did maths. Everyone does maths. Hopefully everyone does maths at school. We call it maths in England, not math, which is the American way of calling it. And what we were doing, you have calculators. And then they try to teach you to remember how to add numbers in your head. And I remember at the time saying to my teacher, why do I need to learn how to do numbers in my head? And my teacher went, well, you won't always have a calculator with you. Ha! Now I do. I even have a calculator on the toilet. It's amazing. But we now have access to unbelievable amounts of computing power, intelligence, and augmenting of ourselves as humans wherever we go. A mobile phone is now a standard human attachment. You go out now. When I went out as a kid, it was, do I have my wallet and my keys? Now it's, do I have my wallet, my keys, and my phone, right? Standard. But mobile means that you can think about applications differently. And that's what we're going to talk about today. Hot topic, AI, ML, scary. Robots are going to take over the world. I have a whole 60-minute separate presentation that I actually gave at Arrow's European conference recently on AI and ML. It's not as bad as it thinks. It's not as far forward as people would have you believe. People are still playing in this space. I'm running a conference in London on AI next week as we're starting to work out as an industry where we are and where we should go. The questions in AI are less about technology, they're more about ethics. They're more about what do we do as humans and what don't we do as humans. But AI and ML are now becoming part of what we do as our daily lives. Some of it might seem like AI, and it isn't. Some of it might not seem like AI, and it is. Whatever you want and whatever you think, AI and ML are going to become a core part of what we do as the human race as we go forward. So we need to understand how we use those. And then lastly, Edge and IoT. Now, Edge and IoT is a fairly cool new term, but essentially it's, I now need computing at the edge. Here's the example that I'll give you. Some of you may have, I don't know if it's out here, Alexa, or Google Home, or we know all these different things. Now, I have Alexa at home. In fact, no, I don't have Alexa. I got rid of Alexa. I now have Google Home. Long story. But I have Google Home connected to my Philips Hue lighting system at home and lots of other things as well. And so I can sit in a room in my house and say, hey, Google, turn out the lights. And within 2, 3, maybe 4 seconds, the lights turn out. Cool, huh? I'm winning. Because 3 or 4 seconds is less time than it takes me to get up off my arse and go and touch the switch, right? So I'm winning. So humans will do this. Now, in that time, what it does is I say what I want, that language then gets translated, sent to Google, Google work out what I said, that then goes to an API which works out which to connect it to, which then goes across to Philips, who then work out who I am, what the API is, send the message back down over the internet to the small box in my house that controls the lights, which then through Zigbee tells the lights to turn them off. 2, 3, 4 seconds. No big deal. What's that got to do with edge, you say? Well, I also have a Tesla car. Now, my Tesla car does autopilot, which is not full self-driving, but essentially what you're doing is it's detecting the distance to the car in front and keeping me in the lane. Now, to do that, it has a unit in it. In fact, they've just updated it, but traditionally it was a thing called a Drive PX2 from NVIDIA. And it was the equivalent of 150 MacBook Pros. The new processor they've just started dropping into the Teslas from the 1st of May is the equivalent of nearly 2,000 MacBook Pros in terms of processing power, dedicated to AI in my car. Why? Here's why. In that car, there's a setting. You turn the knob, and you choose between 1 to 7, which is the distance between me and the car in front. Or in England, it's how many Audis can fit in that gap, okay, when they pull in. Now, what I want is when an Audi pulls in front of me, do you think I want to wait 3 to 6 seconds to talk to the cloud, to work out that it's an Audi, and then talk back down to my car and tell it to stop? No. I need intelligence at the edge, I need it fast, and I need it now. And there's more and more and more applications where it's required either the amount of data being generated at the edge is too much to ship back to the cloud and needs to be looked at there. Think about it. That car is capturing images from 8 cameras simultaneously and radar. Do you think there's enough bandwidth in mobile to send 8 cameras worth of full video back to the cloud? No. If you run a store, a retail store, and you want to use the cameras to track where people are moving within the store and understand how people are shopping, where they're looking, what they're doing, do you have the bandwidth to ship all of that video data in real time back up to a central cloud? Probably not. So more and more you will see more processing power, more storage get closer and closer to where it's needed. The exciting thing for me, though, isn't these technologies, these superpowers on their own. It's when you mix them up together is when innovation happens. Innovation and invention is very rarely someone creating something brand new. What they are doing is taking existing elements and mixing them together in a brand new way. And that's where I look to you as the audience for innovation. Because regularly, we create software, we create technology, we give it, well, don't give it, we sell it to you people. I wish we'd give it to you. But then what you do with it astounds us, continues to amaze us, where people take our technologies and use it for managing the milk production of cows in a way that we'd not thought before, or use it for managing a submarine or wind turbines or something we'd never thought of. And that's where your future is. Your future is in taking these technologies and thinking of ways of using them together that you'd never thought of before. That's where true innovation lies in our industry. So I've talked a lot about these superpowers, and I've talked about how things are spreading out and stuff at the edge and Tesla, etc. What this means is that applications don't look like applications anymore. You'll remember the famous saying from Sun that the network is the computer. Now, the application is a network. No longer does an application sit on one server in one data center. Now applications are made up of components that are spread out across the entire world. So, what does that mean? Well, it means we have to change the way we build applications, the way we support applications, the way we secure applications, the way we distribute applications. It's all changing as it spreads out. Okay? And it's spreading in two directions, and that's what I want to talk about today. But as these applications spread out and people build distributed apps, this is driving a whole new set of priorities for our customers. As our customers work out how they're going to cope with a world where they have to manage mobile, they have to have data in multiple clouds, they have multiple clouds, they have microservices type applications, they have a whole raft of different ways of doing things. It's not just one server in a data center. Why? Well, let me tell you. We have got very well trained as an industry on taking things from one platform to the next, because we've been doing it for 40, 50 years. What you do in IT is you have the mainframe. Then some new people come along with a better way. Let's call it Unix, okay? HPUX, AIX, RISC-6000, you name it. So then we spend time replatforming. We move everything from the mainframe to Unix, okay? Unless you work in government, just leave everything on the mainframe, okay? Then along comes x86. So what do? We move everything. We take everything we do in Unix and we work out over 10, 15 years how we move everything now to x86. Then virtualization comes along. What do? We move everything to be virtualized. Exciting, okay? This is where it goes wrong, though. Because then cloud comes along. And everyone thinks, okay, mainframe, nah, surely we must now put everything in the cloud. No, that's the problem. Cloud is not the next platform. Cloud is part of the way of delivering some of the components of the next platform. It is not the next platform. And because it's just some of the way of part of the components, not all of the platform, we need to think differently. And that's what I want to teach you about today. Now, our customers now tell us they have 5 major priorities as a result of the change in the way we build applications. We're now looking at how we accelerate our journey to use these cloud technologies through either hybrid cloud or multi-cloud or transforming and building modern applications. At the same time, we need to transform what we do with networking and security, because we certainly have to do networking and security differently now. When it was one server in one data center, I could put a security guard at the door, I could put a big firewall in, I'm done. Now when bits of my application are everywhere, firewalls and security guards, they don't always work. I need to think about how I do it differently. And then empowering the digital workspace. This is a fun topic for me, because I started in this space in a way. IT seems to think they like to manage things, okay? IT people like to manage things. So when we first started with computers, we gave people terminals. And the terminals, we let them use, okay? That's why we called them users, because we allowed them to use our system, okay? And then those terminals became PCs. So we decided we have to, and do you know where PCs came from, really, where they started to explode? Do you remember the killer app for PCs? Anyone know what the killer app for the PC was? Lotus 1-2-3. Seriously, spreadsheets. Why were spreadsheets so important? Well, because up till now, I'm in the 1980s. Okay, you can tell by the way I dress. So I'm in the 1980s, and I have access to a mainframe. And I'm trying to do my quick sales spreadsheet, or I'm trying to do, I try and work out what I'm doing. The mainframe is horrible to use. But I can buy a PC and install Lotus 1-2-3 and do my own thing. Shadow IT, 1985 style, okay? And that's what people did. Then IT noticed that people were buying PCs. We have to manage those things. And so they networked them, managed them, secured them. Intel LAN desk, the whole world came on, right? Then we took the PCs and made them portable. Laptops. We must manage the laptops. We must manage all the things, okay? Then people said, I'm not using a laptop anymore. I'm using a mobile phone. We must manage your mobile phone and your iPad and your TV at home and everything. We must manage everything. Because if we do not manage everything, we cannot secure everything. Does this sound familiar? We didn't think that was right. I made a point, probably 8 years ago now, at a board meeting we had, that the whole industry was trying to manage things. Yet my bank delivered an application to my iPhone that allowed me to manage money. But they didn't manage my phone. So why do I need to have you manage my phone to access your stupid applications for your company? They let me manage my money without managing my phone. And that's where we discovered and decided that actually it's not about managing things. Some things, yes, will still be managed, and we do mobile device management, but bigger than that. It's about delivering applications and data securely to anyone, anywhere, assuming devices are compromised. Zero-day trust. All these terms are about the fact that it's not about managing your device. It's about delivering applications and data securely to any device you want to use. That is the digital workspace. Not how do I lock down and manage the next device that you've discovered you want to use. All of that comes together into the VMware vision. This vision has been consistent now for 5 years. You'll see it again at VMworld this year for a 6th or possibly 7th year. I've lost track. Because it works. Our story is simple. We want to help you deliver any application, be it traditional applications or cloud-native applications or SaaS applications. We want to enable you to deliver that on any cloud. And as I've just said, deliver it to any device. Choice is what we're about. There is no formal stack. There's no best way to do things. There is just choice, lots of choice. So it's all about delivering any application to any cloud, from any cloud to any device. But, Joe, I hear you say, I've been to some really cool and trendy conferences recently, and so far you haven't mentioned PaaS or serverless. So how can you be a CTO of a Silicon Valley software company and not mention PaaS or serverless? So here you go. Now, quite often you'll hear in the industry, usually people much younger than me, with better beards and much tighter jeans, okay, talking about PaaS and serverless. Now, the challenge is that where they get it wrong, time and again, is they tell you should be putting everything in serverless or everything in PaaS. And that's wrong. That is where chromatography comes in. Now, chromatography, you hopefully will remember from chemistry at school. And you've got special paper, chromatographic paper, and you put these little dots down here of liquid. And then over time, the liquid spread out into the elements that make the liquid up. Remember that? So all I need you to do now is understand that this is your application, and this is your future architecture. Because you're not going to take that application and just put it all into PaaS. Things are spreading out. They're spreading out so that the right piece runs in the best place to run that piece of your application. Because surprisingly, the best way to run an application is not all in WebSphere or WebLogic on a server that has DB2 or Oracle installed on it. Surprisingly, it's to run bits of your application everywhere. So it's not about moving from one of these to the next. So this is the NIST model of cloud computing. At the bottom, you have infrastructure as a service. renting VMs. Okay? In the middle, you have platform as a service. That's Cloud Foundry and other platform as a service technologies. And then at the top, you have software as a service. Salesforce, Office 365, you name it. Now, where people went wrong is they thought that this is a roadmap of we start on IaaS, then we work out how to move to PaaS, then we move to SaaS, right? It's not a roadmap. It's an architecture. And what you're going to do is you're going to make trade-offs as you build out your architecture. The higher up the stack you go, it says speed stroke stickiness there. Stickiness is a polite word for lock-in. Okay? The higher up the stack you go, the faster and easier it is to deploy, but also the harder it is to get out again. Does that make sense? I mean, think about it. If I wanted to build an email system for my company, I have some choices. I could, down here, go and get some open source components and build an email server, go and get some open source components, build an email client, work it all out, build it, work out how to architect it, structure it, deploy it, manage it, or I can use Office 365 or Google. And that's what people are doing because it's easier. But in other cases, for my company custom applications, I have to run it on IaaS. Because over here, you're trading against operational consistency. To the bottom, if I run everything on the same operating system, on the same virtual machine, in the same data center, my operations are easy. Security, easy, but it doesn't meet all my needs. Alternatively, if I use SaaS for everything, I may have 300 SaaS vendors. Great, but operationally very hard. How do I prove GDPR compliance, for example? How do I do backup? How do I do recovery? How do I do migrations? How do I include new people? It's all very different, so there's no one answer. Now, of course, because it's the technology industry, we can't let a picture like this stay the same for more than 3 or 4 years, so we have to add some complexity. So we've then added 2 more layers. Okay? So now we have CAS and FAS. Excuse me. CAS, I'll come back a bit, is containers as a service. All right? That's the Kubernetes that you heard Pat talking about earlier. FAS, functions as a service, or serverless. See, now I've covered them for you. There you go. So how does this work? Why are there so many layers? Well, it works like this. IaaS is, I would like to rent a whole virtual machine. I will do the operating system. I will do everything. Just give me a virtual machine. CAS is, you rent a whole virtual machine? I just rent a part of a virtual machine called a container. Someone else worries about the operating system. Someone else worries about patching. I just use containers. PaaS is, you manage containers? I use platform as a service like Cloud Foundry to manage my containers for me. I just turn up with my application, and the platform runs my application. I turn up with code, Ruby, you name it. Functions as a service is, you run a whole application? I just run the piece of code I need when I need it. I don't run a whole application all the time. That's very extravagant. Okay? And SaaS is, you write applications? I just rent applications from people that I, don't even know. Now, of course, it's not this simple, because it's not just 5 boxes. It's actually 10 boxes. That's all right, this is where it stops, okay? It doesn't get worse than this. So now, your architectural choices as architects, technology leaders, CIOs, you name it, is you have to have an answer for every single one of these boxes. Because going forward, applications will arrive and be built in your company that will use all of these boxes. Maybe one application might not use all the boxes, but across all your applications, all these boxes will be ticked. Not everything is going to end up in off-premises functions as a service, I promise you, okay? So let me give you an example, because this now looks really scary, right? Let me tell you an example of a customer doing this. Large German car manufacturer, okay? You won't be able to say that in 10 years, but you didn't hear that here. Now, they are running functions as a service, so FAS, on premises in their factories. It runs on small Dell gateways, which are on every single pillar in the factory. Those are talking over a low-rent Wi-Fi called Zigbee to sensors on the car as it goes through, or the car truck actually that it sits on as it goes through the factory. Sensors on the stock levels, sensors on everything. Why functions as a service? Well, I have to read different things at different times. I want to every second check where the car is in the process. But I don't need to count how many wheels I have in the storeroom every second. I can count that every 30 minutes or every 3 hours. It's not that important. What it does is it takes that stuff from there, functions as a service, and writes it down to an on-premises SQL database. So that's IaaS. 2 boxes. Stay with me, okay? 2 boxes. They have then written, using containers on top of PKS, a containers as a service or containers application that looks at that data and does what we used to call ETL, or extract, transform, load for the database people, but essentially looks at that data, transforms it, and writes it out to Amazon S3. So I've now used on-premises CAS and off-premises IaaS. 4 boxes, okay? They then have off-premises PaaS, which is running in Google. So it's Cloud Foundry running on Google Compute Platform that looks at that Amazon S3 data, and from that builds dashboards and a mobile application for everyone to look at to see what's going on in the factory and what's happening. That's off-premises SaaS. 6 boxes, okay? That's it. There's like half a box as well. Because now they have stuff sitting in Amazon S3, external suppliers, the people that provide the wheels and the tires and the gearboxes, they can connect into the Amazon data, and they can then better predict when they need to deliver components to the factory. So I'm on 6.5 boxes now. Now, none of that sounds odd, right? None of that application sounds strange. That's normal. That's how you build applications in 2019, using all 6 boxes. So yes, I used serverless. Yes, I used containers. Yes, I used infrastructure. I used all of those boxes, right, in some way to build that application. Now, 15 years ago, you would have been running it on 1 box in the corner of a data center, and it would have been the sort of CRP, ERM system, I suppose, really, or ERP system, actually. And I would have gone to the SAP ERP team and gone, okay, I'd like to live track what's going on in the factory. I'd like to have a live dashboard on mobile phones for managers. And I'd like external people to connect to the database so they can predict. And you can remember what the answer would be from the SAP team in 2003, right? It wasn't good. But now, this is what you do. So it's not about one of these boxes. It's about lots of these boxes. And so when I say chromatography, hopefully you now understand, these applications are not replatforming to cloud. They're replatforming to a new architecture that includes cloud. All that stuff on the right is cloud, I suppose. But cloud isn't all of it. And in this example, they use multiple clouds, Google and Amazon, to do that. And more importantly, the applications are doing chromatography that way, but they're also doing it that way. Out of the data center, into clouds, to the edge, into factories, into cars, into mobile phones. It goes in multiple directions. So how did we get here? And how does VMware help in solving this problem? So if I take you back 8 years. 8 years ago, we were working on the next thing for VMware. All right? We had ESX. We had 85% market share. We were king of the world. But we realized that that wasn't going to do it for everyone. We realized that applications were changing, infrastructure was changing. So we assembled a dream team of very, very clever people, and me, okay? And in this room, I'm with the guy that invented MPLS. I'm with the guy that invented zones and containers on Solaris. I'm with the guy that invented ESX. And a whole host of people. The guy that built the architecture for eBay. The guy that built the file system for Google. All working for VMware. All helping us build the next generation of infrastructure and application platforms for you. And this is the picture I drew. These are my slides from 8 years ago. I've not changed them. And that's why they're not very good, okay? Because these are really bad pictures. So you understand how a RAID controller works, hopefully, okay? A RAID controller takes lots of smaller disks and makes them look like one big disk. And in that, the RAID controller also builds in fault tolerance and scalability and all those things. The idea being that when a disk fails, we've had RAID, SAN, NAS now for 20, 30 years in our industry. Now, if a disk fails in any of your data centers right now, what is the reaction? Oh. That's it, right? So, oh. If a disk fails right now while you're sat in this room, are you going to get a phone call to run back to the office? No. I hope not. If you are, we need to chat, okay? So the idea was, how do I do that? But instead of disks, they're whole data centers. And instead of a RAID controller, I built an operating system for data centers, which became the software-defined data center. And the mission was this simple. The mission was, we have to be able to lose a data center, and the reaction is, oh, that's it. Now, I can tell you, if one of your data centers goes down right now, you're probably going to have to leave the room. I'm going to make that stop. That's the plan. Now, the challenge is, to do that, I need to be able to move these application components, which are in VMs or containers, from one data center to another. Not easy. Not easy at all. It's easy if you build it at the PaaS layer, Cloud Foundry, which is why we invented Cloud Foundry, was to build it at the PaaS layer. But all these people had all this IaaS stuff and SQL servers and other bits that weren't going to change anytime fast. So we had vMotion. And hopefully, if you're in this room, you know about vMotion. We can move a live running server from one data center to another, even across the Atlantic, live, without downtime. We had a casino 2 weeks ago in America where the river was flooding. And in 15 minutes, okay, right, you build a casino, first thing. You need a data center for the casino, second thing. The casino is next to a river, third thing. Where do you build the data center? In the basement, of course. So, their basement data center was going to flood. 15 minutes it took them to move all of their production casino systems to a public cloud. 15 minutes because of vMotion. But because of a lot more things too. Because when I move a server from one data center to another, yeah, I can vMotion it, but the first people to scream and get upset, network people. Okay? Because we have to, oh, you want to move a server? I need to change the IP address, I need to play with trunk ports, I've got to reconfigure firewalls. That takes like 2 weeks. I can't vMotion a server for you. So, we put a lot of time and effort into talking and working with hardware vendors for networking, and then we decided we would just build networking in software as part of our operating system. And that's where NSX comes from. So NSX means we've moved all the networking, all those layer 3 to 7 services, you know, firewalls, routing, etc., all to be done in software. So now, the networking goes with the server. Its IP address stays the same. Security stays the same. Everything stays the same. Where the server physically is doesn't matter for the network. All we need is a flat layer 2. But the next people to complain, storage team. What, you want got the server running over there, but I've got all the SAN stuff here, and I can't do and we need to asynchronous dark fiber there. Right? Simple. Build a file system in software. That's vSAN. So now we don't care where the storage is. We've built a distributed file store that goes across all of the nodes. Hyperconverged infrastructure is a direct result of this model. Because now what you're racking up in your data centers is not a SAN over there and some networking here and some servers here. It is one hyperconverged node that contains compute and storage. And everything else is done in software. And you'll hear more about HCI next. But of course, the applications haven't stayed the same. On top, we now have Kubernetes, and Knative is one of the examples of functions as a service or serverless that's coming along. So we have to make sure, as we carry on, that our operating system for data centers, which the marketing people like us to call SDDC, or VMware Cloud Foundation, is enabled to support any new application type. So right now, yes, we support VMs, we support containers, we support Kubernetes APIs, we'll support OpenStack APIs. It's just another API to the operating system to give you choice. So now you see we're giving choice. You now have a choice of running any type of application construct on top of this platform. And you can run this platform anywhere, on any hardware, in any data center. But of course, we don't just stay in data centers now in 2019, do we? Of course not. This is where my own high-tech logos come in. You have the cloud. So now we have a multi-cloud operating system. Now, the multi-cloud operating system only makes sense if all the clouds run your operating system, right? So how do you get all the clouds to run your operating system? Answer, you build the best one. And so now we have 4,500 cloud provider partners, VCPP, VMware Cloud Provider Partners, globally, that run our operating system, VMware Cloud Foundation, to operate their public cloud. What does that mean? It means you can freely move your workloads, if you're a casino, from your data center into the public cloud down the road. And yes, that now includes AWS. We now have VMware Cloud on AWS, which means that you can move and live real-time drag your workloads into Amazon data centers, and they stay VMware workloads. We also now have Azure. VMware on Azure allows you to do the same into Azure data centers. Recently announced, launching in America, will hit Europe later this year, early next. But there's 4,500 others as well. Vodafone, IBM, OVH, you name it. I was funny because I went to South Africa last year. I go 2-3 times a year. And one of the interviews in South Africa, the journalist, she looked at me and she said, "We're very excited in South Africa because the cloud is coming to South Africa." And I looked at her a bit funny, like, "What do you mean the cloud is coming to South Africa?" She said, "Well, Microsoft are launching Azure here soon." I went, "I've got 49 clouds in South Africa running on VMware Cloud." The cloud isn't just the big three. The cloud is operating off premises. And why would you go to one of the 4,500 instead of Amazon or Microsoft or whatever? Well, there may be legal reasons. You may find you need to find yourself a Czech cloud provider who uses Czech data centers under European GDPR law, operated by Czechoslovakian citizens. Sorry, it's my wife. Czech citizens. Okay? Does that make sense? Just like we have German data centers running German in the UK and whatever. We have these. It might mean that you need a direct connection locally to that data center that's fast. It might mean that actually you need direct connect. There might be a whole host of different reasons why you need to not use a big one but still have access to that. So we have the ability for you to run your workloads in any type of container, a virtual machine, container, whatever, and across any cloud. But it gets better than that, because we also now, see I do my own slides? We now have the edge, okay? Because the challenge now, I set our organization 3 years ago with a project we called Nano Edge, was how small can I run the SDDC? How small can I run vSAN, NSX, and ESX, and still have a functioning software-defined data center? And the answer is very small, okay? So we got to this box called a Supermicro E200, which is a 6-core Xeon D, really cool little box, NVMe, all that kind of stuff. So you can get 2 of those, and you can run a vSAN cluster, a 2-node cluster, very small, about this big. Someone can carry it on their back. In fact, NATO soldiers do, okay? But we had a problem. The problem was, if you're running vSAN disconnected, I'm getting very technical, sorry here, you need the vSAN witness, which means you need 3 nodes. Well, 3 E200s was too big for what we were doing. So we had to drive new frontiers, new virtualization frontiers, and the big one that we've driven, that's coming out soon, but is in tech preview right now, is ESXi on ARM. So now you can run ESX on a Raspberry Pi stuck on top of these 2 servers to be the vSAN witness. I have trial customers now using 3 Raspberry Pis stuck together with duct tape, okay, at the top of every single wind turbine as a fault-tolerant cluster, which costs them $120. Cool, huh? $120, 3-node fault-tolerant cluster. I mean, they got to the point now where the cost of the Cat5e cable is actually a function. It's expensive in the big picture, right? So we now have pushing boundaries as far as possible. Why? Why would you want to virtualize a Raspberry Pi, Joe? Are you just some kind of mad virtualization scientist that you want to virtualize everything? You virtualize the network, you virtualize compute, you virtualize storage. Now you just want to virtualize my iWatch? No. There's a reason why we're virtualizing things. And the reason is very simple. The VMware Cloud journey and picture really lays out this foundation for you to build these new generation applications, and these new generation applications to spread to anywhere you like. And so whether you want your components to run on-premises using VMware Cloud Foundation, or whether you want them to run in VMware Cloud on AWS, a full managed VMware stack run by VMware in Amazon data centers, or you want to use any one of our 4,500 VMware Cloud providers, or you want to go run it on IBM Cloud, or you want to do Project Dimension. Project Dimension is where we will provide a full managed stack on hardware as a service in your data center. The first of that you'll see is VMware Cloud on Dell EMC, where you can go, sign a contract, and we will deliver a managed instance up to vCenter of the full stack, including hardware, you pay a subscription for. You just use it. We worry about everything else. The options are huge. But also, we can now enable you to run that on the edge. So what you get is the ability for a developer at the top to have access to anything. How do you do that? Well, we provide globally consistent infrastructure. And on top of that, as the leading cloud management provider, people don't realize this, but we are the #1 globally in cloud management software. With technologies such as Cloud Health, Wavefront, and all our cloud management pieces there that enable you to do high level and the greatest level of automation, consistent operations. Consistent automation and operations across multiple clouds and across multiple physical locations to give you a consistent developer experience. What does that mean? Well, it means now a developer can come to one portal, one API, and from that API, they can deploy some stuff in a cloud, some stuff on premises, some stuff in every store, some stuff in every New York police car, all from one interface. We can secure it globally. We can manage it globally. We can back it up globally. Because it's all the same open platform, I now have access to more device types, more applications, more hardware than ever before. So what we're doing is increasing choice. So why do I want to virtualize a Raspberry Pi? Because I want to make it really easy to use and really easy to manage. That's why. So what's next? What's the cool stuff we're doing? Well, I mentioned VMware Cloud on AWS and Azure VMware Solutions. That is full VMware stack running and operating in both Amazon or Microsoft data centers, so you can move to those clouds with a lot less friction. AWS Outposts and Project Dimension. AWS Outposts is where, by the end of this year, you'll be able to go to AWS, tick some boxes, and they will deliver a rack to your data center, running various elements of AWS. You'll be able to do a tick box there as well, and they'll deploy VMware onto that Amazon Outpost in your data center. So you can have Amazon as your hardware provider, okay, that actually is also providing the software. So it's not really like that. It's a cloud provider on premises. Project Dimension is us doing the same. So far announced with Dell, we will announce with other hardware providers too, the ability for you to have managed hardware and software as a service in your data center. If any of you are using Amazon RDS, we now support running Amazon RDS on premises on your existing VMware infrastructure. So you can deploy a cloud service to your on-premises environment. And then lastly, we have Project Magna. Now, Project Magna is the exciting one for me, if I wasn't excited about all this stuff already. Project Magna is next generation AI and ML, okay? Because you'll hear people talk about the software-defined data center. And then you'll hear people talk about the software-defined self-driving data center. Project Magna is what comes after that. So, self-driving is like, desired state stuff. So there's sort of three stages of management. Stage one is what most people have today, which is you install some monitoring software and some management software, it sends some alerts, and you respond to the alerts. Stage two is what you're starting to see today, and you'll see us launch with Cloud Automation Service and other things at VMworld this year, which is more around what we call desired state. Desired state is where you say, I want my system to look like this. And then the system keeps it looking like that. So, if a system fails, the system will automatically bring it back up. Okay? That's like a self-driving car. I want to get to the office. You get in the car, it drives you to the office. As things change, as cars arrive, as trucks come and ambulances do whatever, it works it out, but it gets you there. That's the self-driving data center. Intelligent thinking, looking at change and adapting itself as it goes, based on what you define is the best way to do things. Project Magna is the next level. Project Magna is where instead of when you get in your car and say, I want to go to the office, it goes, okay, and drives you to the office. Your car now goes, no, we're going to the hospital today. And you go, why? And it says, well, I've been looking at your watch and some of the readings we've got from the machine in your house, and I've decided that you need to go and have a checkup. That's the next level, right? And from a data center perspective, that is, okay, look, I know you think it should look like this, but we think, the intelligence I've applied thinks you should have 7 more of those, 3 less of those, 10 of those, and none of those. And why have you built that? Right? We've started on some early versions of this. Automated tuning is one of the things we're doing. We have a product, I can't tell you which, you'll see some stuff later at VMworld, where we have a very specific tuning team that tunes that product to within an inch of its life, okay? And they're down to what we call marginal gains. So typically when they're tuning an environment, they'll get 5%, 3%, 8% improvement in performance from that system. We ran an early version of Project Magna against it, 67% performance improvement in one run of regression-trained AI. Think about if I apply that to the entire system. We applied this to a working application, a full stack application, and it started doing things we didn't expect. It started changing the frame length on the virtualized networking based on the application utilization, because it realized that increased in performance. Something you'd never think of doing. Would you think of changing frame length on the network based on particular? Never, right? So there's some amazing stuff we still as an industry have to learn, and we're making sure that those next generation applications, as they are spreading across multiple places, across multiple environments, they're getting beyond the point where humans can understand and humans can manage. We need automation. We need intelligence. So from a security perspective, something like app defense. which is one of the early versions of our ML product that you'll see coming out, and is becoming the de facto standard now in customer sales, now looks at your environment, learns the behavior of your applications, and when those applications stop doing what they normally do, it locks the computer network, adapts to what it should be doing, and shrinks the attack surface. So what we're doing very simply is, for the many years we've been until getting here, we've been helping you have a platform that gives you openness and choice. We've been helping you get to the point where you can truly deliver any type of application on top of, from, using any cloud, and deliver that securely to any device. And the technologies we have are all going towards helping you paint that vision. So with that, I thank you very much for listening to me for the last 55 minutes. And I hope you have a great day at the rest of eForum. I will be here for much of the day, so if you see me wandering about, please come and have a chat, and I'd love to hear your thoughts on what I had to say. Enjoy the day. Thank you.